guys, starting chapter 9. So chapter 9 has a lot of information in it, especially section 1. So I'm going to split section 1 into 2 days. So we are talking about graphing quadratic functions. When you graph a quadratic function, it's a parabola. A quadratic function should be written in this form. You should be familiar with that. You have already had functions that were in this form. When we FOILed, your answer was in this form. It's also called standard form. So a parabola is, when you graph it, should look like this, should be symmetrical. The ones that we're going to graph will have arrows on the ends of them. When they talk about flattening the curve on the news, this is what they're talking about, a parabola. So when they want to flatten the curve, they don't want the curve to be up here, they want the curve to be more here, which means we're talking about COVID, less people getting it. This would be more people getting it, this would be less people getting it. Okay, so we have an axis of symmetry. So a parabola is symmetrical. The axis of symmetry is the line, is your line of symmetry. We also have a vertex. The vertex is the point that is in the middle. It's your point of symmetry. And we have something called a maximum or a minimum. This is a maximum because this is the highest point that we can have. If our parabola opened this way, this is a minimum because that's the lowest point that we can have. Okay, so starting off, you're just going to pick points to graph it. And it's not easy to pick points to graph it because you don't know where your parabola is going to be on your graph. So just like when you graph a linear equation, you can pick whatever you want for x. So we're going to pick 1, 0, -1, -2, -3. And for no particular reason, we're just picking those points at this point. So you would take it and plug it into your equation. Here's our equation. And take your number and plug it in. So y equals 3 times 1 squared plus 6 times 1 minus 4. So when you do all that, we get 5. And just to save time, I'm not going to plug them all in. You need to plug them all in and make sure that yours match up with mine. But important thing about 0. When I plug in the 0 here, I wind up with -4. Thinking about this, if I have 0, -4, if I were to graph 0, -4, 0, -4 would be here, which is on the y-axis, which means that's your y-intercept. So anytime you plug 0 in to your equation, you're getting your y-intercept, and that's an important point that we need. So the rest of our points turn out to be okay. So notice how these are both 5s, these are both -4s, and this is in the middle. So when you graph this, you're going to see a pattern occur. So here's my graph, and here's my points. So we have 1, 5, so 1, 5 is here, 0, -4 is here, -1, I forgot to graph this one. I knew something didn't look right. 1, 2, 3, 4, 5, 6, 7. Okay. So it didn't look right because I didn't have my axis of symmetry, which there it is. So if you look at your graph, this is your lowest point. This is your y-intercept, and notice how in the middle, if I were to make a line of symmetry down the middle, which you don't need to make, I'm just making it to show you something. This is my middle point. Notice how this is 1 away on the left, this is 1 away on the right. This point is 2 away on the left, this point is 2 away on the right. So you can see that your parabola is symmetrical. So the directions on this part, on number 1, said to identify the axis of symmetry and the y-intercept. So this is our axis of symmetry, and sometimes they want an equation for the axis of symmetry. So if this were our line, the equation for this line is x equals -1. So that's the equation for our axis of symmetry. And they wanted the y-intercept, so here we can see this is our y-intercept. So the y-intercept is -4. And again, there's your y-intercept right there. Anytime you have a parabola, you're looking for patterns. Patterns are very important when we have parabolas. All right, so number 2. All right, so on number 2, it says to find the vertex, the equation of the axis of symmetry, and the y-intercept for each function. So our equation is this. Okay, so the first thing we need is they want the axis of symmetry. So we're going to use this formula. X equals -b over 2a. This formula you're going to use in this entire chapter. So if this is our equation and we need to figure out what our x is, we need to know a couple things. So this is my a, this is my b, this is my c. That makes this my a, this my b, this my c. I don't need c for this equation, so I'm just going to focus on these two. So a equals 2 and b equals 4. I'm going to take those, plug them into that equation. So this is giving me an x coordinate. So x equals -2 over, I did that wrong, -4, that's my b, over 2 times 2. So x equals -1. So do they want the equation for the x? This is it. That's my equation for the axis of symmetry. X equals 1. Then they also want the y-intercept. So my y-intercept, easy enough to get your y-intercept, just like I said before. When x is 0, it's whatever your y is. So you're going to plug 0 into here. So if I plug 0 into here and multiply it out, this is my y. So my y-intercept is -3. So those are the two things that you need for that equation. Could you graph it based off of those two things? Yes. Here we'd have to do one more step and get the y coordinate. So I'll show you how to do that real quick. So I'm going to take this x equals -1 and plug it into this equation and solve it for y. So y equals 2 times -1 squared. So when I figure out the answer here, this is 1, 2 times 1 is 2, -4 minus 3, y equals -2 minus 3, so y equals -5. So I have a coordinate, -1, -5. So before, on the first problem, we didn't really know where to start, we were just picking any number. Now I know that I have a coordinate as -1, -5, and my y-intercept is -3. Technically, I could just graph those from there. They're not asking me to graph it, but I could, because I have 2 points and I know that things are symmetrical. Since we're not taking it to the next step, I'm not going to graph it, but what you would do from here is you can pick points now. I know that one of my points is -1, 5. -1, -5. So since everything is symmetrical, pick points around that. So one above that is -2, -3, 0, 1, and 2. You can pick those points, you can plug it into your equation and solve it for y, and then you have points to graph. Okay, next one. So for the next one, part B, same thing. Here's my equation, and they're asking me for the vertex, the equation of the axis of symmetry, and the y-intercept. So starting with the vertex, we have our formula. x equals negative b over 2a. So I'm just going to figure out what my a and my b are. The a is negative 1, your b is 6. Plug it into that equation. So x equals negative 6 over 2 times negative 1. So your x equals 3. So then you're going to take this, you're going to plug it into here. So y equals, and this is important, it's negative 1 times this. 3 squared plus 6 times 3 plus 4. So that's 9, that's negative 9. And when we figure that out, we get 13. So my first coordinate is 3, 13. That is your vertex. From here, you can say what your equation for your axis of symmetry is. It's this, x equals 3. So we know that that's the line of symmetry. How do we get our y-intercept? Plug 0 in for x. So if this is 0 and this is 0, your y-intercept is 4. Those are the 3 things that you need for that question. Okay, next question, number 3. Okay, determine whether the function is a maximum or minimum. So for letter A, we have this equation. So this f of x, you can replace with y. So y equals negative 2x squared minus 4x plus 6. Just by looking at this, I have a visual in my head. I know what the equation is roughly, or the parabola roughly is going to look like, because this is negative. So I know that when I graph it, since that's negative, it's going to look like a frown. It's going to go like this. That's a frown. So it's going to have a point somewhere up there. That's going to be my highest point. So this equation is a maximum. And then we need state the maximum or minimum value. So how do I do that? I go back to that same formula as before. Negative b over 2a. So my a is negative 2, and my b is negative 4. Plug it in. So b is 4, 2 times negative 2. So x equals negative 1. And then I plug it in to this to get the y coordinate. So y equals negative 2 and when I solve all of that, I get y equals 8. Okay, so now I have a coordinate, negative 1, 8. And now I know what my maximum value is. My maximum value is the 8. Because if I were to go graph this, negative 1, 8 would be somewhere over here. That's going to be my highest point. I already said it's going to be a frown somewhere like this. That's my highest point, and that's the vertex. So the highest point is at 8, and my vertex is at negative 1, 8. This negative 1, x equals negative 1, would be your line of symmetry. Okay. Then state the domain and the range of the function. All right, so the domain, that's your x coordinate. Could you pick any x coordinate you want? Yes, so that means it's all real numbers. Your range is here. So the range is y such that y is less than or equal to 8. We don't have any points that are greater than 8. Anything lower than 8 could be our y coordinate. So that's part A. Part B is a separate question, asking the same stuff. Okay, so g of x doesn't mean anything other than changing it to a y. So y equals 2x squared minus 4x minus 1. Is it a maximum or a minimum? Since this is a positive, I'm going to think of positive as a smiley face, because that's a positive thing. So if I was graphing it and I had a smiley face, then that would mean that that's my lowest point, so this is a minimum. Okay, then they want me to figure out what is my lowest point, what is my minimum. So go back to the same formula, x equals negative b over 2a, my a and my b, a equals 2, b equals negative 4, x equals 1, just like before, plug it back in. And when we solve that, we get y equals negative 3. So my vertex is 1, negative 3. This tells me a lot. This tells me my axis of symmetry. If they wanted the equation for the axis of symmetry, it's x equals 1. And this tells me that my lowest point, my minimum point, is negative 3. And we need our domain and our range. Domain, you can pick any number you want, so it's all real numbers. Your range depends on this y. So this is the lowest number that you possibly will get. So your range is y such that y is greater than or equal to negative 3. And that's it.